everybody, we have another find the limit problem. In this problem we're going to be applying this concept, L'Hopital rule. So the limit as x equals to 0 for tan hyperbolic tangent over tangent. So we know tangent is sine over cosine, so at 0. So we know tangent is equal to sine over cosine at 0. Let me give us a variable too. Let's just call it x. That's equal to sine x over cosine x. And we know sine is 0 and 1 at x equals 0. So we know here for hyperbolic tangent, if we find the limit at 0, it will just be 0. There's no difference between hyperbolic tangent and tangent other than the domain restriction, and because all it is hyperbolic is just plotting the unit circle using hyperbolas, so you're still going to get 0. Tangent x is also 0. So we have an indeterminate form, so we have to take the derivative of this. So the derivative of tangent of hyperbolic tangent is hyperbolic secant squared x, and the derivative of tangent x is secant squared x. So not much of a change from the regular trig functions. So if we apply the limit now, we know secant, hyperbolic secant is going to be equivalent to 1 over cosine squared x. And regular secant would be 1 over cosine squared x. And then we can simplify that to the limit as x approaches 0. And we'll wind up with cosine squared x over hyperbolic cosine squared x. When you do that, you get cosine at 0, we know is 1. 1 squared is 1, so we have 1. Hyperbolic cosine, get the same numbers, the only difference is where it's defined and it's same unit circle values, just defined on the hyperbola. So this is 1.